before we get started, any questions over the homework? Any questions on the homework or the homework assignments? All right. So this is the last type of problem with solving we're going to be looking at. So we have the square root of 2x equals the square root of x plus 7 minus 1. So the first step, is there one radical? No, if not, even them out. Well, we have two radicals, yes? So we'd want one on either side. We do have one on either side, so we do have them evened out. Now our next step is to put both sides to the nth power, just kind of like we've been doing. Which means we're going to put both sides to the second power. We're going to square it. Now the left-hand side is kind of nice because the square root and square will cancel, leaving us with 2x. Now just like yesterday, here we have two terms being subtracted, which means I can't just square our radical term in the one. We actually have to multiply this thing all the way out. So what we're saying is that we have the square root of x plus 7 minus our 1 be multiplied with the square root of x plus 7 minus 1. We're going to have to multiply this thing by itself. We're going to have to multiply it all the way out. Now the left-hand side is going to be kind of nice because it's still just the single term 2x. Now our first product is going to be the square root of x plus 7 times the square root of x plus 7. Here I'm going to go on and just write it out because we're going to have the square root of x plus 7 times itself. It's being squared. But we know that the square and second power are going to cancel. So that part is going to be kind of nice. Our next one we're going to do is the square root of x plus 7 times negative 1, which is going to make it negative square root of x plus 7. Now we're going to move on to the negative 1. Negative 1 times our square root of x plus 7, again, is going to be negative. You're good. Square root of x plus 7. Well, negative 1 times our square root is going to make it be negative 1 times the square root of x plus 7, or just negative x square root of x plus 7. Is what we have. Yeah. Yeah, because we're just distributing this out. So we multiplied through our square root of x plus 7 first, which gave us these two terms. Now we're doing the same thing with negative 1. Well, here, and then our other one, negative 1 times negative 1, is going to give us plus 1. So we have to multiply that all the way through. It's a little funky because we're not used to having to multiply with the square root of something more than just a variable or a term. Questions on how we got to this point here? Combine like terms so far? Because at this point, the only like terms are negative square root of x plus 7 and negative square root of x plus 7. Well, how many of them do I have? 2. Because our negative square root minus that same square root, negative 1 minus 1 is negative 2. Now we do have like terms from that square root being squared, simplifying out, because our like terms are our 7 and 1, and 7 plus 1 would give us 8. Okay. Questions on what we've done so far? Because the main thing we've done so far is just square both sides and simplified down to what we have on either side. The left-hand side was kind of nice. Square root and square canceled out, giving us 2x. The right-hand side, we actually had to multiply the whole thing out to get to x plus 8 minus 2 times the square root of x plus 8. Okay? Questions on steps 1 or 2? Okay. Step number 3, which up to this point we've kind of ignored, But step 3, are there any radicals left? Yes. If so, repeat steps 1 and 2. So since there are radicals left, we go back to the top. Is there one radical? Yes. If so, get it by itself. Which means everything besides that radical we need to move to the other side. Almost. Because we can subtract x from both sides. Our 2x minus x would give us x is equal to 8 minus 2 square root of x plus 7. I think you did the 8 minus 2. So we're going to move that x over first. Now we need to move the 8 over. We're going to subtract it from both sides. Now it might be very tempting that 8 minus 2.
How would it be on that step where you subtract the x? How would it equal x?
So 2x minus x. I have 2 of them. I take 1 away. Yeah. Because on the right-hand side, our x minus x is going to give us 0. On the left-hand side, that 2x minus x, since they are like terms, we can simplify that to 1x. Does that make sense? Next, we're going to subtract the 8, because on the right-hand side, our 8 minus 8 will simplify out, leaving us with our negative 2 times that x plus 7, square root of x plus 7. X and 8 aren't like terms, so it'll just be x minus 8. And lastly, to get that radical by itself, we're going to divide both sides by negative 2. Like I said, we have x minus 8 over negative 2 is equal to the square root of x plus 7. Again, questions, anything not making sense? Because, I mean, looking back at what we've done so far, there's a lot going on, but if we think about individually, step by step, what we're doing, the individual steps aren't that bad. Trying to do all of it at once, a bit much, but we're just taking it one step at a time, and especially with these bigger problems, that's the main thing to focus on. Because now we're down to this here, x minus 8 over negative 2 is equal to the square root of x plus 7. Is the radical by itself. Put both sides to the nth power. Well, our nth power in that case is, in this case, would be 2. Now the right-hand side is going to be nice to us. Square root and square are going to cancel, telling us that we have x plus 7. Now the right-hand side simplified nicely. Now the left-hand side would simplify nicely as long as we don't have two terms being added or subtracted in the top or bottom of this fraction. Well, we have x minus 8 on top. We're going to have to multiply this out again. Let's do the bottom of the fractions first, because when we multiply two fractions, we multiply the tops with the tops, bottoms with the bottoms. On bottom, we have negative 2 being multiplied with, and negative 2 times negative 2 is 4. Thought we'd start there because that's a little bit nicer. On top, x times x is x squared. X times negative 8 is negative 8x. Negative x times 8 is again negative 8x, and negative 8 times negative 8 is plus 64. So we also have to multiply that x minus 8 by x minus 8. And what that gives us is x squared minus 16x plus 64 all over 4 is equal to x plus 7. Questions on any of this here? Or at least following kind of what's happening, yep. All right. Check my colors. Yep. This fraction, this division on the left-hand side seems like it's going to be a big pain, something we're going to have to work through, yes? What happens if I multiply this side by 4? I scale that side up by 4. The 4 and the 4 on bottom would cancel, yes? Well, our first thought, there's no way we could just do that. Well, yes. I can't just multiply one side by 4. I have to multiply both sides. All we're doing is scaling the function up. We're increasing it by that set factor, which is fine. Because we can also divide everything by a set number to scale it down. We can't so much do this with, it's a little tricky with variables. You can multiply through by a variable, that's fine. Not dividing. Dividing is removing. And why this is nice is because the left side we get 16x squared minus 16x plus 64. We have no fractions, we have nothing that we're going to have to work with to get that to be the same with our x plus 7. Here when we distribute, x times 4 is 4x. X times 7 is 28. We've got to get this thing equal to 0 because we have an x squared term. So the first thing we can do is subtract 4x from both sides. Telling us we have x squared minus 20x plus 64 is equal to 28. Telling us x squared minus 20x plus, not 34, yes, 36. We'll go on and factor. Since the third term's positive, the signs are the same and match the sign of the middle term. So we say negative and negative. Only factors of x squared are x and x. Now 36 has several factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Yeah, I'm going to say 2 and 18. And I'll go on and check it just to make sure. X times negative 18 is negative 18x. Negative 2 times x is negative 2x, giving us the negative 20x that we need. Now, since we do have two things multiplied together equals 0, one of these is going to be 0. So we said x minus 2 equals 0. And we can solve it by adding 2. Minus x is equal to 2. Further? Okay. And here we can add 18 to both sides, telling us x is 18. Let me see. You're good. No, I'm just going to look back at the whole thing. Yep. Looks good. Yes. Yeah, I think you just added that there. Yeah. And again, those little steps, those things happen to all of us. Because I worked this problem out earlier and for some reason didn't subtract the x at the top from 2x, added it, gave us 3x, and messed the whole thing up. But 2 and 18, well, I'm going to do one thing that y'all can't do. That. I feel like that would be a very nice thing to have. We could do with paper, just hit clear. But it'd also be the most frustrating thing in the world. Because if you accidentally hit it and... But let's check 18 first. So on the left-hand side, I mean, we could type this all in. 2 times 18 is going to be 36. Square root of 36 is 6. 18 plus 7 is 25. Square root of 25 is 5. 5 minus 1 is 4. So x is not 18. It is what we call an extraneous solution. It's a solution that we get from solving, but does not work in the original problem. It's an extraneous solution. 2. Now on the left-hand side, 2 times 2 is 4. Square root of 4 is 2. On the right-hand side, 2 plus 4 is 2 plus 7 is 9. Our square root of 9 is 3. And 3 minus 1 is 2. So x equals 2 is our solution. This is the main reason step 3 is here, because if we do end up having radicals after we finish squaring it, we're going to have to do it and keep doing that till the radicals are all gone. That's it. There's the second problem. There is no homework attached to this, but this here, we're going to say 10 bonus points. If you want to turn it in and get it done, that's 10 bonus points. But that is the end of what we're going to be able to cover in Chapter 5.